Video on the usage of the Beam Shaping PyMoDAQ toolbox. So in this video I will show you how to set up properly your program in order to compute an hologram to produce images. So we are going to restrict ourselves on a so-called 2F setup, and we are going to produce intensity only images. So first of all, you'll have to define in the preferences which kind of SLM you are going to use. So in the Beam Shaping preferences, you'll have a SLM section where you can choose one or several SLMs. So here you have a Pluto one from the HoloEye company. Then you'll have to select which algorithm that you want to use. So we are going to use a projection one called the MRAF, which will require to define a hyperparameter here, this mixing ratio. Anyway, so I can initialize that algorithm, and here I'll have a few plots with the metrics and also what will be the field on the modulative plane and in the output plane. For the moment, nothing much, it's just random phase producing random images. But I have to set first and make sure that my input field is correct. So here I'm using a Gaussian laser beam, and that is filling almost entirely the area here that we see in green of the modulator. In the left panel we have the amplitude, and on the right one the phase, so there's no phase as input for the moment. And in the various options of the field loader, you can really tweak and modify the shape of it. But for the input beam, nothing much to be done. What's really interesting is to compute something on the target beam. And in here, I'm gonna select another image. Whoops. Load, and I want to calculate actually what would be the hologram to produce this cat. And I can already set a region of interest for the algorithm to perform the calculation and optimize the thing only in this area here for my cat. And if I want to have a smaller cat, I can just rescale a bit my image, and I'll have a smaller image here I can select. So once here it's done, I have here the values corresponding to this region of interest that has been directly printed in here. So I just apply that mask, and I'll start with a random phase and a hyperparameter of 0.5. First of all, what I can do is to reset the phase in case I ran the algorithm just before, and I can do one step of a Fourier transform to propagate my beam into this corresponding 2F setup. If I do just that, I obtain this output images, which is here the amplitude completely random because the initial phase is random. But then I can start one step of the algorithm, and I can then also run continuously the algorithm. And very quickly I will have already modulation of the phase able to produce in the output plane this kind of cat. I can stop the algorithm whenever I want, and I have also here the evolution of the matrix efficiency within this area, which is evolving, increasing, while the root mean square error is decreasing, meaning that the shaping is getting better and better. What if I want to change my target? Well, I just have to go onto the target field order again, and let's say now I want to use a more complex mathematical expression. For instance, two circles on a line. I can load that thing, move my area here, and then apply some more specificities to this shaping. I will apply an angle here, 30 degrees, and a distance between the two of 700 microns. Here you go. And I reset my initial phase and perform again the computation, and you see that very quickly I obtain at least an image approaching with a given error the target field. So now that we have computed an hologram, what if we want to really send it to the modulator and perform an experiment where we produce this image? Well, it's as simple as clicking on this button, which will try to send the phase calculated here onto the modulator, given that there is a modulator declared in the PyMoDAQ dashboard. And this will be for another video.